Hello there, gamers. Welcome to this wonderful little stream. My name is John. I am your professor somewhere in the universe, and I'm doing this stream to supplement our material a little bit, to give you a little bit more introduction to Godot and to coding specifically, right? You've probably already watched a video on my intro to the editor in making scenes and projects. I have another video that you can watch after this, which will get you up to speed with coding with conditional logic and using user input. But this is to sort of fill the gaps a little bit. This is for the roughly the second week of Godot material in my class, and it's really to introduce you to scripting writ large. And if you have never done any scripting or coding, that's totally fine. This is going to take you from the ground zero, I guess, the bottom floor, the entry point to coding. This should be a lovely little entry point to your first foray into coding with Godot. You don't have to have any coding experience at all in order to understand this. We're going to go over the fundamentals from the ground up. And if you have some coding experience with coding languages, I suggest skipping ahead to the part, I'll put a timestamp in here, but to the parts where you can see the Godot editor and you can see specifically how we're doing coding in Godot. I also have to, please forgive me if I sound a little weird today. I just got 4 teeth filled and I cannot feel the left side of my face. So I feel crazy recording this right now, and that's just where we're at. That's the adjunct faculty lifestyle. Okay, anyway, enough about me. Let's talk about coding. So, coding is written, all code is written in scripts, right? This is true in about 99% of all programming languages on Earth. They're written in these files called scripts. They're written in files. It is words. Coding languages. Code is typically a file or a set of files, that is a set of words that the computer reads from top to bottom and then executes as a set of instructions, almost like your tabletop games, but almost like a tabletop game in and of itself, like how we sort of learn the rules to a game and play it by following instructions. Code is basically instructions that are written for computers that are then executed by computers, right? And so in most programming languages, code is executing from top to bottom, right? So if you have, if this were a piece of code, right, we would see this first line I happen first, and then the second line I happen second, right? If the computer were reading that piece of code, it would do the first thing first, and then it would do the second thing second, right? So code typically goes from top to bottom, okay? Now, how we sort of make meaningful things happen in code is with instructions, right? And these instructions use, they sort of tell the computer to do things. And typically when we tell the computer to do things, we need to specify a certain amount, right? Like if I were to move something on the screen, I would want to move it by a certain amount, right? Or if I wanted to damage an enemy, right? I would want to damage it by a certain amount, right? And these sorts of amounts or properties, all right, we call them variables in code. And a variable is just sort of is like a value of some kind, a piece of data that is stored in memory, and the computer can always make new variables. The computer can always retrieve the existing contents of a variable, and you can always change the contents of a variable, okay? It's just like in math class, like in algebra, how you say like x equals 1. We do the same thing in computer, right? So in GDScript, we use this, GDScript is the Godot programming language, which we're gonna start learning. And so the syntax for creating a variable in GDScript is we write the word var, and then say space, and then we write the name of the variable, and then we give it a value, right? And in this case, I'm giving this variable the value of 1, but you can give variables all sorts of different types of data as values. So you can give a variable a floating point number as a value, so we could give it 1.5. We could give it an integer, like we've given it here. We can also give variables the values of strings, like maybe we want to write down a name of something. We could make a variable called like my cool name, and it could be like John the awesome professor as a string, right? And that's a string is a type of data that is used, it's sort of, we print it out for humans to read, but it's not necessarily relevant for computers. And there's lots of other different types of data that variables can be. But in most basically we very often use numbers as our variable data types, right? So for instance, in this case, I've created this variable called x, and I've given it the value of 1. And this next line is a little tricky, right? What we're doing here on this next line is we're saying, okay, now let's change the value of x equal to, whenever you have a variable and you sort of say, you have a value, and then you say equal to, that means you're assigning whatever's on the right-hand side of the equation to the value on the left, right? So we're setting this x value equal to what's on the right. And in this case, we're doing a couple things at once. We're both setting the value of x to this new value, which is going to be itself plus 1. And in this case, we're looking up the old value of x, so we can say x equals 1 plus 1, and then we set x equal to that. So x equals itself 1 plus 1. And if we were to run that the first time, we would get 2, right? Because 1 plus 1 equals 2. But what's cool about variables is if we were to run that again, if we were to say x equals itself plus 1, and it looked up the new value, right, then we would change x into 3 because it would be, right, we would have already set it to 1. We would have started out as 1, then we would have updated it to 2, and then if we were to run the equation again, we would update it to 3. Okay, so this is a nice way that we can have variables that are updated over time, which is really powerful. Now, another key component of scripting language is the idea of having a function. And if nodes in Godot are like nouns, right, and adjectives are kind of like properties are kind of like adjectives, right? Like a sprite, for instance, is an object that can have a position property, right? That's kind of like an adjective. It can have a size, right? How big it is, how small it is. Well, functions are kind of like verbs, right? So they sort of move the nouns, right? They change and transform and act upon these nodes, these nouns, right? So a function can move a sprite across a screen, or a function can delete a sprite, or create a new object, or listen to a button press and then do something, right? Functions are, they do all sorts of complicated behavior, and there's lots of built-in functions that we have access to that we're going to be calling a lot. And we also always have the ability to create or modify functions. And you can think of sort of creating functions kind of like a factory or a pizza restaurant, right? They're sort of like things that need instructions, right? So for example, if we had like a pizza making function, we might want to say something like this, right? We might want to say first step in making a pizza is to make some dough. Then the second step in making a pizza is to spin it around in the air for fun, which is very important. Then we would want to add sauce and then add cheese, and then we would cook it, and that would give us a pizza, right? And the way that these functions look, this is sort of specific to GDScript, but it's also very similar to Python, or, you know, there's a couple other programming languages where functions kind of look like this. First, to declare the function, we say func to let the computer know that we're making a new function. Then we write down the name of our function. Then we have these parentheses here, which will take an argument, which I'll get to in a minute. Then we have to have a colon, right? And then after the colon, everything that is indented is considered part of the function. So this stuff is considered part of the function, right? These lines here are part of the function, but this line down here is not a part of the function, right? It's a separate line entirely. Okay. Now, to jump back to these parentheses, right? These are for arguments, and arguments are like extra instructions that you can insert into the function to like customize it a little bit, right? So if we were using our make a pizza function, we might want to have like a toppings argument, right? So then when we are making our pizza, we would have the, you know, dough part, we'd spin it around, we add the sauce, we add cheese, and then we can add the toppings, and we can add whatever toppings we specify when we call the function, right? So first we declare the function, where we sort of outline all the steps that are required to do it, and then later in our code we actually call the function. That's when we say like, hey, go do the thing, right? So in order to call the function, we just write the name of the function followed by parentheses, and then any arguments that we want to pass in. So if I wanted to make a pepperoni pizza, I would say make a pizza and then parentheses pepperoni. And then if I wanted to make like a mushroom pizza, I would say, you know, make a pizza parentheses mushrooms. Yeah. So that's how you sort of call a function, and you can call a function with various different arguments. And again, right, you can always create your own functions, like your make a pizza function, or you can use a built-in function to your environment. And these built-in functions are often called methods as well. So in Godot, we're going to use this language called GDScript, and this is a custom language made just for Godot, but it's very similar to Python, okay? And something that's important to know about coding in Godot is that scripts are always attached to nodes, okay? There's some special cases where you can have some scripts in a global space, but for the most part, you always want to have your scripts attached to a node, and you can only ever have one script attached to one node. And another sort of helpful thing to know about coding specifically in Godot is that there are three fundamental functions that all nodes have. They have the ready function, which executes when the node is loaded into the scene for the first time. They have the process function, which executes once every frame, and they have an input function, which executes whenever you interact with the computer, like moving the mouse or pressing a button. And what's cool about these functions is that by default, they're actually empty, okay? So Godot doesn't do anything with them, but it gives them to you and lets you change them and fill them with whatever code you want, okay? And typically when we're sort of interacting with things in our scenes, we're going to be putting our code inside of one of these three functions, okay? Finally, nodes have properties and methods. We've already seen the properties like the position property, the transformation property, the scale property, the modulate property, all the things that you can edit from the inspector. Those are properties, and you can also edit them via code, okay? And then nodes also have methods, right? They have certain functions that they can do that other nodes can't, right? You can kind of think of methods like, I like to think of like Pokemon cards for this example, right? So like Pikachu has a property which is like its cost, right? If you have a Pikachu card, you have like a cost that it has in the top that you have to pay for when you play it. It also has a property like its health and its attack power and stuff, but then it also has a special ability, right? It has like lightning bolt or whatever, and that is a method, right? That's a special ability or a function that only Pikachu can do, right? And if you used a different Pokemon, like Squirtle or something, right? Squirtle would have a different summoning cost and a different HP and different numbers, and Squirtle would have a different method that it could use. It would use like Squirt Gun attack or whatever, right? And those are two different things that those objects can do, and there's special abilities that are unique to that object, right? And that's kind of what methods are. And different nodes have different methods which you can use to your advantage. Yeah, and I've already mentioned this, right? If nodes are nouns and functions are verbs, then properties are like adjectives, and properties are the same ones that you can edit in the inspector. You can also edit them via code. And these methods, right, the things that I'm talking about, right, they're special abilities, right? And a very simple example is the hide and show methods, which allow us to make different nodes visible or invisible, which I'll show you in a minute. So I'm going to switch to Godot now. I believe this will just work. Whee, look at that, nice and fun. So you should be able to see the editor. I hope that it is nice and high definition. Looks pretty good on my end. So I'm going to go ahead and start showing you around, right? So I'm going to go to the 2D view, and I actually just want to check really quickly on the stream to make sure that it's legible. I know that it's important to be able to see these things. Ooh. So hold please while I do some stream finagling, fiddling if you will. Always be fiddling. Let's see, what quality can we check? Let's do that. And then, yeah, that looks nice and legible. Okay, so, yeah, thanks for waiting. I'm going to show you scoding now, right? So, in our 2D view, right, I'm going to do some very simple examples where we make some things move around, right? In order to see things moving around, it's good to have something to see. So I'm going to take our friend the robot, and I'm just going to save this scene. I'll call it main. And I'm just going to move this. How do I move this? Okay, yeah, I'm going to say, sure, you can see that. I'm going to save this scene and call it main. I'm just saving it to the regular old file browser. Okay, now you see we have our main scene, and when I run the project, I'll select the current scene, and I'm also just going to make it appear over here. Okay, so now you see that we have this main scene that's running, right? Very cool. So in order to actually do any coding in Godot, what you need to do is you need to create a script, right? We need to create one of these script files. And the best way to create a script file is to click on the node you want, and then you can either right-click on it and go down and click Attach Script, or you can just click on this plus button over here, this Attach New Script, right? And again, here I have this script dialog which pops up, and we're going to specify the name of the script. And I'm not going to change anything else. I think that's fine, right? By default, it's going to take the, I guess by default, it's going to give it the name of the scene. It's interesting that it's called main. Anyway, you can name your script whatever you want. I'm going to call it main, and that's fine. And we'll see now that we have this little script icon, right? This little sort of scroll, this parchment thing. And that's to show you that there is a script attached to this node. And when we'll also see down here, right, we have this main.gd and this little gear icon. The gear icon shows you that it's a script because it like does things. And you can either open this script by double clicking on the file down in the file browser, or if you just click on this script icon, it will also open up the script right here, right? And so we're going to see already that we have some stuff here, right? We have this script. I'm also going to make this window a little bit bigger, which you can always do by clicking on this these arrows in the top right, and you can shrink it by clicking them again. And I have a bunch of reminders. That's fine. Don't worry about that. Go away, reminders. Thank you. Great, now you know my to-do list. Anyway, yeah, I know. Okay, thank you. Great. So, so we have this script, right? And these, I'm going to make it bigger. And we'll see that we have a couple of things right out of the gate, right? So we have this boilerplate line up at the top. This is just to let the editor know which type of node we're using so that we can access its special properties and methods. Typically, when you create a script, it'll just insert this for you, so you don't need to change this or do anything with this, right? Then in this template, you see we have a couple of lines, right? So we have this ready function, and what I'll say is that there is also this little void thing. This is an optional thing that Godot adds to be even more specific. You don't need to have these in your function, so I didn't include them in the description earlier because I think they're a little bit complicated. But as you'll see, that this is also just a perfectly fine function. Okay, so basically, if you see these void things, you don't need to worry about this void stuff. Okay. If you're curious, right, this is the thing that Godot is returning, I believe, right? If you want to return a value, it's specifying the data type that you're returning, I think. Anyway, so we have this ready function and we have this process function. And you'll also see that we have some gray text, which is kind of like a hint, right? This gray text is a comment that is here for our eyes only. And it says that this is called when the node enters the scene tree for the very first time. That's the ready function. And you'll see that the process function is called every frame. Okay, and then it also says all this other stuff about delta. You don't need to worry too much about delta. But what is important to know right now is, right, these comments are for humans, right? This is not code that is going to be executed. And as a matter of fact, right, if I deleted this hashtag sign, it'll turn this into code, and Godot's going to start complaining because it's going to try and read this and understand it, and it doesn't know what any of these words mean, right? So if you ever want to leave yourself a note or leave your collaborators a note, you can always create a comment by typing the hash sign, and then you can write in whatever you want. You can write my cool comment, right? And comments are super useful because, again, right, when you're collaborating with other people, or even when you're collaborating with yourself and you're working on a project with a lot of different components and you're working on it over a long time, very often, this has happened to me all the time, I come back to something like 2 or 3 weeks later and I have no idea what I was trying to do, right? Again, coding is a very specific type of instructions that computers are really good at reading, but when we as humans try and read code, we can often get confused and it's sort of hard for us to parse. So it's a really good idea to leave some comments explaining what your functions or your code does so that you in the future or your collaborators can understand what you're talking about, right? So we have these comments, right? And these comments are sort of describing what these different functions do. And as I already mentioned, we have this ready function, which executes once when the node enters the scene tree for the first time. And we have the process function, which happens every frame, right? And to show you the distinction between these two, I'm going to do something, I'm going to call a special function, which is going to print out a little message for us in the console, okay? And all that might sound a little confusing at first, but I'm just going to show you how it works and then I'll explain what it is, right? So in order to do this, in order to print out this special message, you have to call the print function, the print method built into the editor. So in order to do that, I'm going to type the word print, P-R-I-N-T, and you'll see that as soon as I start typing, Gato is smart enough to suggest all of these different possible functions or properties that I might want to use here, right? You don't have to worry about what all of these are, but just know that these are like suggestions, right? This is sort of like an autocomplete, right? So I'm going to use the arrow keys to go down to print, and then I'm going to hit return. You don't have to return. You can also just type in parentheses, and that also is fine. And then in this area here, you can print out whatever you want, right? So I'll just print out the number 100, okay? And now when I run the scene, you'll see that down here in the console, right, here is the number 100, okay? 100 got printed out one time in the ready function, okay? And again, right, we can use any sort of data. We can print out, Gato has lots of different types of data, and you can print out any sort of data. So if I wanted to print out a message to myself, I would type some quotes, right, because I need it to be a string, and strings are always wrapped in quotes, so the computer knows not to consider it code. And I can write my message, right? So I can say like, hello world. Woohoo. And now when I run my scene, you'll see that there is hello world in the console, right? And again, the editor's just, the scene is sort of over here. I'm just moving it out of the way. Yeah, it's important to note, right, again, that this string has to be wrapped in quotes, because if I just took the quotes away, Gato's going to be confused because it's going to say, hey, what are you talking about? I don't really know what hello world means. It's going to start thinking that you're interpreting this as code, not as like a string itself. But strings, it knows, you know, when you print out when you use a string, the computer sort of recognizes that it's just a bunch of characters grouped together, and it's going to spit them out, and a human on the other side is going to read them and know what to do with it, right? But the string itself, the computer's not going to worry about what it means or does. And strings are really useful for, you know, printing out strings into the console is really useful for understanding what's happening in your game while you're making it, right? And as you sort of saw, right, this area down here is the console. So we see that when we run the game, we switch to this output tab, right? We have the debug tab and the shader editor tab. We also have this output tab, and any messages you want to write to yourself get printed out here in the console. And just to show you the difference between the ready function and the process function, right, I'm now going to go down here and print out a value into the process function. I'll print out the number, like, you know, 2 or something. And now when I run the game, you'll see that at the top, we had hello world, but then very quickly, every single frame, we started printing out the number 2, right? And it's probably a good point to pause and talk about frames themselves, right? A frame in video games is just a snapshot. It's a moment in time. And as a matter of fact, frames themselves are, for the most part, let's see, how do I do this? I'll make this here, and yeah, that seems probably pretty legible. I will search for a picture of a frame, movie frames, images. Yeah, that's perfect. So in a film, right, in a classic film, an analog, old-timey movie from way back when, the way that you would create the illusion of motion is by having static images that you would whip past a projector at a rate of around 23 frames a second, right? And by showing 23 still pictures quickly, one after the other, you know, 23 of them a second, that convinces the human eye that you're actually creating motion. And that's been true of moving graphics ever since then. Film, television, computer monitors, videotapes, all of these methods of creating images on screens are just done by creating images one after another after another. And computer graphics are no different. And so when we talk about frames, like your frame rate in a game, right? If you're a gamer, you might know that like people typically care about frames per second, and you might be very concerned with the idea that you need to have 60 frames or 120 frames per second. That just refers to literally the number of still images that your computer can draw every single second when you're playing the game. And when we are creating games, when we're using Godot to make games, we do the same thing. We create still images many times a second. And the process function is a function that gets called every single time Godot goes to draw a frame. So when Godot goes to draw a new frame of your game, first it checks to see if you have any nodes with scripts, then it checks to see if any of those scripts have a process function, and then it does the code in the process function from top to bottom. And when it's done all of that code, then it goes and draws the frame. So what you can see here, right, in our script, is we've printed out a bunch of number 2s because we printed one out for every single frame of the game, right? And to show you an even more sort of dynamic example, I'm going to do something where I create my very first variable. So I'm going to create a variable up here. And the reason why we have to create it up here is because when we create things inside of functions or inside of places, they are stored inside of that function and they get sort of erased later. That's sort of a confusing way to put it. It's basically very good practice to create your variables at the top of the script. Okay, so I'm going to create a variable called my variable, and I'm going to make it equal to 0. And then down here in the process function, I am going to print out my cool variable, right? And you'll see, as soon as I start typing the name of my variable, it pops up right here at the top, and I can just hit return. But then, if I were to just do this, right, if I were just to run this script, we would see pretty quickly that this just goes 0, 0, 0, 0, 0, 0, right? That makes sense. However, what I can do is I can then, after I print out my variable, I can say, let's now make my variable equal to itself plus 1. And what this is going to do is when I run the project, you'll see that the number starts ticking up very quickly, right? And the reason why that's happening is, again, because what we're doing, every single frame we are calling the function. First, we're seeing what the last variable of my variable was. Then we want to change the value of my variable to itself plus 1. So every frame we are increasing it by 1. And that's why we were rapidly increasing over here, because we are rendering many frames very quickly. Now, this is all well and good for sort of like stuff that we don't care about, but let's actually start taking some of this information and using it to create something, right? To create a sense of interactivity in our project, right? Currently, we just have this robot who's just sitting here in this square. But let's take this idea of having a variable and let's use it to make our robot move, right? As a reminder, our robot has a transformation property, right? It has a position property. And this position property has two components, an X component and a Y component. And again, as I mentioned, right, all of these properties can be accessed from code at any time. So maybe instead of printing out my variable, I'm just going to comment out this line so that we don't see it anymore in the console. Maybe I'll just print out the position. Let's see. So I'll print out position, and let's just see what that looks like when we run it. Okay, so here is the position that got printed out, and you'll see that it corresponds exactly to the position that's in the editor, right? 127 pixels over and 149 pixels down from the top is the position of this image. Okay, so if I just wanted to access the X part of this position, I could use something called dot notation. And dot notation you can think of a lot like a file path to a thing on your computer, right? Like when we have a file path, we typically say like, we say like in my home folder /me/downloads, right? Loads. Right, when we store things on our computer, we have like them in a path like this. Also, when you go to pages on a website, this is also how pages on a website work. And you can kind of think of it like this is a folder this downloads folder is inside your user folder, is inside your home folder. Dot notation is the same thing, but for accessing properties or data of objects in code, right? So this position object, this position is a vector2, and it has an X part and a Y part, right? And instead of doing slashes, we use dots. So basically what I'm saying is in order to get the X position, the X component of the position, you can say position dot X, right? And if you wanted to get the Y component of the position, you could say print position dot Y, right? And now when I print it out, you'll see, right, we on this first line, we printed out the X position, and on the second line, we printed out the Y position. Okay, and that's useful because we want to use, maybe in this example, I just want to make my sprite move along the X-axis. So what I can do in the process function is, instead of just changing my variable, right, maybe I can do this instead. So I'll comment this out, and I'll say, instead of changing the variable, let's say position dot X equals itself dot X plus 1. And now, every frame, I am updating the position of my sprite. So when I run the scene, lo and behold, we will see that we have a sprite that is moving across the screen, which is pretty crazy, I think. I think that's pretty cool. Yeah. And if we were to change this number, right, it would change its rate of motion, right? If I changed it to 2, it would move twice as fast, right? Because we're moving it by 2 spaces every frame, right? If I changed it to 5, it would move by 5 spaces every frame. So that's pretty cool, right? Now I'm going to change, maybe I also want to change the Y position. So I'm going to go ahead and do that. I'm going to say position dot Y. And it's kind of a lot of work to type out the same thing twice in a row, and programmers love to try and take shortcuts. So a nice little shortcut you can use to both modify and assign a variable is basically you can say plus equals and then the amount you want to do. And this plus equals is the exact same as saying itself equals position.x equals position.x plus 1, right? That's position.y plus equals 1 is just a shortcut to do this exact same thing, right? You also have minus equals and times equals and divided by equals, but I'm just going to do plus equals, and now we're going to run the scene. And you'll see that we're moving diagonally, and we're moving diagonally because every single frame, we're both moving over and down 1 pixel, and then we're drawing. And that tricks us into thinking that we have diagonal motion. Now, if I wanted to change my rate of speed, right? Because this is really what this number is, right? This is how fast we're moving, how many frames we're moving every second. This is basically our speed, right? I could sort of type these in by hand every single time, but A, I might get it wrong, and B, it's kind of a hassle to sort of have to type in several things all the time, right? But I could do this, and that would be fine, right? And we'll see this thing flies across the screen. But if I wanted to really sort of make this a little bit smoother, what I could do is I could create a variable, right? I'll create a variable up here, var, and I'll set it, I'll call it speed, and I'll set it equal to 1. And then down here, I can say, let's just add our speed, right? And this is essentially the same thing as adding 1 to it, because we have assigned speed, a value of 1 at the top of our script. And then when we're executing our code, we're checking, hey, what's the value of speed? Oh, speed is 1. And then we assign it to that number, right? And so now when I run the scene, we have it moving at the exact same rate. And what's really nice about this is, if I'm trying to change things, right? Because again, game design is a very iterative process. So maybe I run my game a little bit and I think, oh, you know what? I don't quite like the way that works. Let's make it go twice as fast. I just can change this one number, and then bada bing, bada boom, it's moving twice as fast. And I only had to modify something at the top, okay? Now what's really nice, a step above that is being able to, maybe you want to modify things without even having to open the script editor, right? Maybe you want to just be looking at your scene thing and maybe you wish there was a way to just, edit one of the properties that are the speed, right? Because speed is essentially a property, right? It's just a value that we have created. And it would be really nice if we could create our very own properties. Well, you in fact can very easily create your own properties. All you need to do is go to the script editor, go to the variable that you want to have access to as a property from the property inspector, and just export it. And the way you export a variable is you do @export. You just write this little export flag. And then as soon as we save it, we'll see that over here is the value of the variable in the property inspector. And that's pretty cool because again, right, if we're just like editing our scene and we have a bunch of other stuff we're working on, maybe we're working on like the level or whatever, and we're like, oh yeah, and maybe we just want to, make it go faster, right? I can just change the value of the speed and then I'll run the game. Bang, and look at that. Now, as a reminder, children inherit properties from their parents, including their position. So that's why you saw this sprite move with this other guy. So what I'm going to do actually real quick is I'm going to create a new node. I'm going to just add a node 2D. I'm going to reparent. I'm going to make it the scene root, which is just going to switch it so that it's the scene root, it's the main node, and then now we have our robot as a second node. I'm going to delete this other little dude. And what's really nice about having scripts with exported variables is that when we have instances of them, right, if I were to duplicate this node, we would see we have an icon with the same script attached to it. But these are now different values, right? So if I were to make this speed 1 and this speed can be 4, then when we run the game, we see that this one is moving at a different rate, right? And that's pretty cool. It's pretty cool that you can have variables with different rates like that, right? So I think that's about gonna cover it for this particular video. Again, this video is really just meant to show you the fundamentals of coding. What I'll say is if you want to learn more about how any of these functions work, the first place to check is the documentation. And Godot has some excellent built-in documentation. So for starters, you can always, if you're curious about any particular function, you just have to hold down Control on Windows, or I think it's maybe Command or Alt on Mac, and then click on the function, and that'll pop open the built-in documentation that will tell you all about the function, right? And we can see there's all these sections, which we can learn about different methods that it has, all these cool different things that are built into the function. Actually, sorry, this is the documentation for Node itself, and ready is a function inside of that. Yeah, okay. But so like if we wanted to check out the documentation for sprites, right? We could right click on sprite, go down to, oh, I don't think you can see it. If you right click on sprite and go down to the very bottom right below here, there's a button that says open in documentation. And then we open up the documentation all the way for Sprite 2D, right? It's really, really cool. Finally, if you want to see even more cool documentation, right? If this built-in stuff isn't enough for you, you can go to the online docs, which is even more robust. So you just click online docs, open in online docs, and I have a weird computer, but it'll work for you. And if it does, if you click open in online docs, that'll take you to the documentation, which is, I'll just go to it on the website. It's at godoengine.org/docs. And again, this button does work. I just have a really weird computer. There it is. Oh, now it's working. Great, cool. And again, right, it'll pop you up right to this web page where you can see a sort of more nicely formatted version of this documentation, and you can see all of the other nodes, okay? So again, I'm going to pause here because, and if you want to sort of learn more, right, take the next steps in coding, I recommend watching the next video in this little series, the Introduction to Conditional Logic, and that'll show you how to take this motion, right, these sorts of dynamic things that we've created, and turn them into interactive things by actually listening to user input. So I hope that was helpful. Please reach out with any questions, and I will see you